distribution for x1, that is my pi. So that is, so let's keep the chain in the background. So I start with some initial distribution pi. P is the transition probability matrix. I assume it's a homogeneous chain. So transition probability is the same across the entire sequence. And I keep on calculating pi p to the power n for like that. And let's say theta is the stationary initial distribution or the invariant distribution, so that theta times p equal to theta. Can you tell me why this happens? For any pi that you may start with. In fact, this convergence is uniform in pi. So if I use all the results that I have written down here, can you use them to prove that? So I have a pi p to the power n there, and it doesn't matter if I put the same p to the power n with theta, right? Why it doesn't matter? Because it is the invariant distribution, right? So this is exactly equal to this. So this theta p to the power n is theta. And then this means what? This is less than equal to and now remember what I said about the contraction coefficient? It's strictly smaller than 1. So what will happen? So this will go to 0 because this is bounded by 2. So this convergence is uniform, you see. No matter what pi you take, it uniformly converges to that. Okay. See, I didn't use any probability theory anywhere. I only used properties of matrices. This approach is originally due to a Russian mathematician called Dobrushin. So Dobrushin, when he was writing papers on Markov chains, this was the approach that he was using. So some people call it Dobrushin's approach to Markov chains. You don't need to know Markov chains. If you know matrix and if you know properties of stochastic matrices, you can prove everything. And that's how it should be. After all, I mean, the results are essentially properties of stochastic matrices. Okay. Do you all understand the main arguments here? There are certain things that I have stated without proof, but I have told you how you can do it yourself. But this is the main idea. Yes? Spelling of Dobrushin. Okay, I have to check that myself. Okay, I can actually give you the references for Dobrushin where you can find these things. Dobrushin. Okay, that's simple enough. R.L. Dobrushin. So he had these papers with some other people in theory of probability and applications, Soviet mathematics. No, not that one, sorry. So theory of probability and applications is sort of the main paper, and then he had several ones. Okay, so that he did in 1956. So it was in mid-50s he was doing this. This is his approach. And this approach is liked very much by a group of people who are neither mathematician per se nor probabilist, by image analysts who actually need something more than that. For them, they don't assume that the chain is homogeneous. Okay? Instead, they assume that these PIs are transition probability matrix which may be different, but there is some similarity, there is some regularity among the PIs, and I'll give you the regularity condition, okay. So for them, proving the result using usual approach of probability theory or properties of Markov chain is much more difficult. So they use this approach. See, here I am using p to the power n, and if I have something like p1, p2, these are say the transition probability matrices. Then what shall I have? I will have pi p1, pi p2, p3, like that. And then each pi may have an invariant measure or stationary initial distribution, right? So there will be theta 1, theta 2, theta 3, like that, okay? So there may be theta 1, theta 2, theta n, like that, where theta I, pi is equal to theta I. So the first question they ask is, will this theta is, see, if there has to be a limiting distribution, then this theta is first have some limiting distribution, right? Otherwise, you can't hope that this will converge to something. So the question that we are trying to answer is, as n tends to infinity, will it converge to a distribution? So now my chain is inhomogeneous. It's not homogeneous anymore, okay? So the question that they are asking, it requires, if you want to answer it in affirmative, it requires two conditions. One condition should be about these theta i's, the other condition about the pi's, rather on the contraction coefficient of these pi's. And let me state you both the conditions. So let me state for you both the conditions.